Welcome back, dear students. Let us begin the second part of the lesson, in which we are going to learn about practical views, merits and limitations of statistical significance. Let us have a look on statistical significance. The degrees to which a research outcome cannot reasonably attributed to chance or random factors. It is determined during significance testing and given by a critical p-value, which is the probability of obtaining the observed data if the null hypothesis were true. Significance generally is a function of sample size. The larger the sample, the lesser likely one's findings will have occurred by chance. Importance of statistical significance: if you consider that this statistical significance can be understood with the help of graphs. Statistical significance refers to the likelihood that a relationship between two or more variables is not caused by random chance. Its two main components are sample size and effect size. A statistical hypothesis testing, the hypothesis is unlikely to have occurred given the null hypothesis. According to null hypothesis, there is no relationship between the variables in question. So, statistical significance we are having understanding with an example. Statistical significance is the most practically used in hypothesis testing, such as formulating a null hypothesis and alternative hypothesis to test whether actively smiling can make people happier. So, restate the predictions into a null and alternative hypothesis. Null hypothesis may considered as this: there is no difference in the happiness between actively smiling and not smiling. For instance, null hypothesis, if it is the case, then what is the alternative hypothesis? Actively smiling leads to more happiness than not smiling. So, testing the statistical significance in quantitative research, data are analyzed through null hypothesis, significance testing or hypothesis testing. This is a formal procedure for assessing whether a relationship between variables or difference between two groups is statistically significant. Hypothesis testing always starts with the assumption that the null hypothesis is true. Statistical significance and its levels, if you see that a critical region, which is also known as region of rejection, is a set of variables for the test statistic for which the null hypothesis is rejected. That is, if the observed test statistic is in the critical region, we reject the null hypothesis and accept the alternative hypothesis. Significance level equal to probability of type 1 error, which is usually denoted by alpha. The results are written as significant at alpha % level of significance. Now, coming to the examples of the p-related value, the value significant at 5% refers to p-value less than 0.05 or p less than 0.05. Similarly, significant at 1% can be denoted as the level of significance be taken at 0.05 or 5%. Statistical significance and relevance with a chance. Statistical relevance refers to the likelihood that a relationship between two or more variables is not caused by a random chance. In essence, it is a way of providing the reliability of a certain statistic. Its two main components are sample size and effect size. Measure of statistical significance. Researchers use a measurement known as the p-value to determine statistical significance. If the p-value falls below the significance level, that is size of the critical region, the result is statistically significant. If the p-value is a function of the means and standard deviation of the data samples. So, significance in data, what it means? Statistical significance refers to claim that a result from data generated by testing or experimentation is likely to be attributable to a specific cause. A high degree of statistical significance indicates that an observed relationship is unlikely to be due to chance. Statistical significance can be misinterpreted when researchers do not use language carefully in reporting their results. Several types of significance tests are used depending on the research being conducted. Coming to the determination of statistical significance, how you can determine. Statistical significance is used to provide evidence concerning the plausibility of the null hypothesis, which hypothesize that there is nothing more than random chance at work in the data. Statistical hypothesis testing is used to determine whether the result of data set is statistically significant. Generally, a p-value of 5% or lower is considered to be statistically significant. The format of statistical significance is that statistical hypothesis testing is the result that is obtained when p-value is lesser than the significant level that is denoted by alpha. If there is a large sample size, the small difference in the research finding can be negligible if you are sure that the difference did not arise out of a fluke. What it means that unlikely chance of occurrences. Let us understand statistical significance through a calculation. Consider this following question. Find out the statistical significance using the Z test if the sample mean is 15, population mean mu is 12, population standard deviation sigma is 4 and the sample size is 30. Then the solution is as follows. Given parameters are x bar sample mean 15, mu 12, sigma 4, n equal to 30. The test statistic is calculation after simplification, it is 4.10. With the formula we can say that the test statistic value is 4.10 and the test critical value at 5% level of significance is 1.96. Since the test statistic is more than the test critical value, H naught, that is mu equal to 12, is rejected. Let us summarize the part 2. I have discussed the statistical significance by providing the information inputs on the meaning, importance, examples, testing levels, relevance of the critical region, p-value, data determination, format and calculation of statistical testing statistic. Dear students, I hope you understand the concepts what I have explained so far. We will continue in the next video. Thank you.